Okay, this is lesson 2.6, multiplying and dividing rational expressions. To multiply a rational expression, it's very much like just multiplying fractions. You multiply across the top and across the bottom. But what makes it slightly more complicated is that when it's a rational expression, the first step is to factor. So you can see which factors you can simplify. So the first step is to factor both the numerator and denominator. Simplify by dividing by any greatest common factors. And then multiply the rational expressions by multiplying the factors of the numerator by the other numerator and the denominator by the other denominator. Last step, state the restrictions by determining the zeros of the original factored denominator of both factors. So that sounds kind of complicated, but basically we're factoring top, bottom, multiplying the factors on the top, multiplying the factors on the bottom, dividing away any common factors, stating restrictions, just like we did when we were simplifying. So the only difference between multiplying rationals and simplifying rationals is that you actually have to multiply across the top and across the bottom, and then it's just like simplifying a rational. So first step's factor. So as we did in the last video, I'm just going to start and say I did all my factoring work on a separate piece of paper or off to the side. If you're doing a test, you do have to show the factoring. I'm not going to show the factoring to keep the video short. So if I factor the top, I end up with a common factor of 3 and two factors of m minus 8n and m minus 2n. Now this is a complex trinomial. If you common factor the 3, it becomes a simple trinomial, but what makes it a little bit more complicated is the extra letter. But if you factor using decomposition, looking for numbers that multiply to c and add to b after you common factor, you should be able to factor that one pretty nicely. In the denominator, if I factor it, I end up with factors of m plus 5n and m minus 2n. In the other fraction, in the numerator, I end up with m plus 5n, m plus 3n. And on the bottom, I end up with a common factor of 2, m minus 8n, and m plus 8n, because we have a two-term polynomial which ends up being a nice difference of squares. So if you have trouble with the factoring, go review your decomposition, factoring complex trinomials, and difference of squares, because the bottom one is a difference of squares. So now that we're fully factored, the next step is to multiply the rational expression. And you can do that first, or you can start dividing away common factors. Because if you multiply the top by the top, all you're going to have is this entire expression as one numerator all multiplied together. And this entire expression is one denominator all multiplied together. So what that means is if there's a factor on the top of this fraction, the bottom of this fraction that's also on the top, you can divide it away. Or if you have a factor that's on the bottom of this, on the bottom of this rational expression, that's also on the top of this rational expression, you can divide them away as a common factor because they would end up being a part of the same expression. So I'm going to look for my common factors and I'm going to divide them away. M minus 2n is on the top and bottom of the same fraction. Over here we've got m plus 5n, m plus 5n, we can divide those away. And in this fraction we've got m minus 8n and m minus 8n. And all that leaves us with is a 3 on the top here, an m plus 3n on the top here, a 2 on the bottom, and an m plus 8n on the bottom. So now I'm going to do my multiply step. Anything that's left on the top, I'm going to multiply together. 3 and m plus 3n. And on the bottom, 2 and m plus 8n. And there we have it. This is our simplified rational expression after multiplying. So factor, divide away common factors, multiply, state restrictions. This one's complicated because there's two variables. So to state the restrictions, what we actually have to do is, I'm going to use this space down here, is we have to take each of the factors in the denominator that have letters in them and say they can't equal 0. So m plus 5n cannot equal 0. And now we have to pick a letter that we're going to isolate all of these for. And it can be m or n. You pick the one that's easier. It's much easier to isolate for m than it is for n. So I'm going to isolate all these for m. So I'm going to move the 5n to the other side, make it negative 5n. So there's one of my restrictions. And if I do that with all of my denominators, I end up with a bunch of different restrictions here. M minus 8n can't be 0. Move the 8n. There's another one. And my last one is m plus 8n can't be 0. So I get that m can't be negative 8n. And I end up with 4 restrictions, taking each of these factors and saying they can't equal 0 and isolating. Even the ones that divide away and the ones that stay, all of the factors in the denominator of both fractions. So we end up with 5 restrictions, and at the end we say m can't equal, open a bracket, and let's order these, negative 8n, negative 5n, 2n, and 8n. And there's my restrictions. It's easier if you only have one variable, but it's not that much harder if you have 2. Just pick one and consistently isolate for that one. So either m every time, we say m can equal, m can equal, m can equal, m can equal, or n every time. Pick the one that's easier. There's another example here, b. I want you to try that one. Make sure you look for common factors first when factoring, and give it a shot. Factor fully, multiply across the top, divide away your common factors, and then look for restrictions. You can try that now, pause the video, or you can try it after the video. Example 2. Dividing rational expressions. Now, dividing a rational expression is actually much like multiplying. There's only one difference, and it's like dividing a fraction. When you divide a fraction, you have to flip the second fraction and then multiply. So we have to do that when we're dividing expressions as well. Most of the rest of it's the same. We still factor, and then flip and multiply, and then divide out common factors, and then state restrictions. However, we have to look in one extra place for restrictions, and we'll discuss that at the end of the example. So let's do A. I am going to factor, and actually these are all simple trinomials, so I can talk about the factoring and not spend too much time here. We need 2 terms that multiply to negative 21 and add to 4. So those would be 7 and negative 3. So I get a plus 7 and a minus 3. That's my factors on top. On the bottom, I need numbers that multiply to 15 and add to negative 8. That would be negative 5 and negative 3 divided by numbers that multiply to negative 7 add to 6. That would be a plus 7, a minus 1. And on the bottom, multiply to negative 5 and add to negative 4. That would be negative 5 and 1. And now we are fully factored on top and bottom, and we're set up to divide. Now, when you divide fractions, you actually flip and multiply. So the next step is to flip the fraction, the second fraction, and turn this into a multiplication question. So first fraction stays the same, a plus 7, a minus 3, a minus 5, a minus 3. You could have divided away the a minus 3 here because you notice it's common in the same fraction, and that's fine, but I caution you with dividing the common factors before flipping the second fraction, just because when you start to divide away the common factors, it has to be when it's set up as a multiplication, not when it's set up as a division, because you may divide away something that's not actually in the bottom of the fraction, because remember, we're flipping this one. So flip it first and then look for your terms that you can divide away. So anything common on top and bottom can be divided away. So here we go. We've got a minus 3 in top and bottom. We got a plus 7, top and bottom. We got a minus 5, top and bottom. Almost everything divided away. We're just left with a plus 1 over a minus 1. And now we have to look for restrictions. What makes this harder is we have to look for restrictions in both denominators once it's been factored, here and here. But when we flip the second fraction, this denominator goes up to the numerator. And this numerator comes down to the denominator. So we actually have to look in 3 places. Anything that was ever in a denominator needs to be considered for a restriction. So this is a denominator, this is a denominator, and then when we flip it, this is a denominator. So we're looking at the top and bottom of the fraction that's flipping and the bottom of the one that's not. 3 different places for restrictions. Now we're going to try to do restrictions a little bit more efficiently this time. We're going to say a can't equal, and we're going to look at the factor and decide. We're not going to write the little expressions like we did up here every single time, because we can start to get a little bit more efficient with our math. So what can't a be in this factor? A minus 5? Well, a can't be 5. And now they're going to end up out of order here, but that's okay. What can't a be in this factor? 3. This factor, 5 again, we already listed it. This factor, negative 1. And now we look for where we flipped it. This factor, negative 7. And this factor, positive 1. And there we've got our restrictions. And we could reorder those if we want to. I'm not super worried about whether they're in order or not. Just make sure you have them all there. Okay, and here's a second example for you to try on your own as well. Make sure you common factor anything that needs to be common factored before trying to factor. And it looks like we've got a difference of squares in here, a complex trinomial, and then 2 more simples. So some more practice with our factoring. Try that one on your own and then check the answers on the course website after you're done. Thanks for watching, and I'll see you next time.